But we also say there's no evidence for a beginning universe.
No. There's a difference between evidence and proof. And I think what happens throughout your book is that there's an absolute 100% standard of proof required for anyone who wants to say that the universe had a beginning.
That's not what we're talking about.
And well, that's what the singular, to suspend the Born-Guth-Vilenkin theorem simply because there are models that could circumvent its conditions is to require an absolute proof.
No, it's not. It isn't. It just isn't. It does. We're not looking for an absolute proof. That's just not
I'm
correct.
saying that there's evidence of a beginning because the back extrapolation.
Well, can we agree there's no empirical evidence for a singularity?
Bill, is being described as an epic debate between one of the leading proponents of intelligent design and an atheist science journalist and podcaster. Dr. Stephen Meyer and Phil Halper squared off on Justin Brierley's program for over 3 hours, and the main topic was the Big Bang and fine-tuning. And it didn't take long for your name to come up in the debate, Bill, so we've isolated some excerpts that I think are accurately representative of the highlights of the debate. Obviously, with 3 hours, we can't do the whole thing, but we're going to look at the Big Bang and beginnings in this particular podcast. Phil Halper, Skydive Phil, as he's also known as, it seems he's becoming a known science popularizer and an influencer with the release of his new book, Battle of the Big Bang, co-authored with Niayesh Ashfordi, who is professor of the Department of Physics and Astronomy at the University of Waterloo, and he's also associate faculty at the Perimeter Institute for Theoretical Physics in Ontario. Phil is also a fellow of the Royal Astronomical Society. He frequently interviews the most prominent people in the field, so this will be a good debate. Dr. Stephen Meyer's book, The Return of the God Hypothesis, was published in 2023. It continues to make a splash. Steve is everywhere these days. And before we get into this first video clip, Bill, I'm sure that our listeners are interested in hearing a little more about your speaking trip in England. You just returned. The Kalam and cosmology were some of the main topics on this tour, Bill.
Yes. Skydive Phil, or Phil Halper, has been for a long time a determined critic of the Kalam cosmological argument that we've interacted with several times, Kevin, in the past. And I found that he is feeding objections to people like Alex O'Connor, with whom I had a dialogue. Now, although, as you say, Halper is a popularizer, he has sought to associate himself with professional cosmologists, though I think it has to be said he doesn't always represent the Kalam cosmological argument accurately to the persons that he interviews.
You know, Justin Brierley has a good strategy of getting his guests to offer what they think their opponents' views are so that they can avoid straw men. And here Phil gives what he thinks are the main points of Steve's book. Here's the first clip.
It's a big book, so I won't be able to cover all of them. But I think the ones that are going to be relevant today are, well, there's a few. So the first one is called the Kalam cosmological argument. And the Kalam can be expressed in different ways, but the standard way of expressing it, I think Stephen does do it this way in the book, is to say, okay, everything that begins to exist as a cause, the universe began to exist, therefore the universe as a cause. Now that's stage one of the Kalam cosmological argument. A lot of people think that's it for the Kalam cosmological argument, but it isn't. There's a stage two that says, okay, we actually think that this points to a God. It's not just a cause. And Stephen even makes the case that, it's actually, the monotheistic God. He makes a case against polytheism and deism and things like that. So that's one argument. Another argument is that the Bible sort of gives us reason to believe there was a beginning of the universe. So if the Bible is true, then we should expect there's a beginning to the universe. And of course, the evidence for the beginning of the universe that Stephen goes into is that the Big Bang has shown that there's a universe has a beginning. Now, there are other arguments that the universe has a beginning coming from philosophy. But the ones that Stephen focuses on in the book is from cosmology. So that's the sort of Big Bang side of things. The fine-tuning argument, of course, there's many different ways that you can express the fine-tuning argument. Some make it a deductive argument, some make it a probabilistic argument, but they're all going to trade off the notion that the constants of nature are very, very unlikely to have life-permitting values given naturalism or atheism, or however you want to put it. So the best explanation, and this is Stephen's kind of main explanatory framework, is to use what's called deductive reasoning. So you look for the best explanation. So it's slightly different to deductive or inductive reasoning. So you're basically saying, here's the evidence, what's the best explanation? So Stephen thinks that the best explanation for this fine-tuning is that there's a God. I think in earlier books, Stephen was only saying that there was an intelligent designer and not really saying it's necessarily God. But I think in this book, he comes out and says, no, I'm now advocating for God, and it's the God of Judeo-Christian theism.
Yeah, that's the subject of the book. It's a book about God. I was pleased to hear Phil acknowledge both philosophical and cosmological evidence for the beginning of the universe, Bill. It's something that you emphasize.
Yes.
But how well was the Kalam fine-tuning? And by the way, he's speaking kind of fast there. He talked about abductive arguments. How was that handled in that clip, Bill?
I thought it was very fair, Kevin. I thought he did a good job of summarizing the case that Steve presents.
Your work comes up next, Bill. Steve responds to Phil's summary. Next clip.
How did
Pretty
Phil
well
do
on
that?
the fine-tuning, but the cosmological part, there's a important subtlety. I did a podcast not too long ago with William Lane Craig, talking about our different approaches to developing the cosmological argument. I think his deductive Kalam argument has force, because I think that as best we can tell, the universe had a beginning, and the alternative models that attempt to portray some sort of pre-Big Bang state that is materialistic, I think are mainly incoherent and not satisfactory. But I think that part of the inference to the best explanation approach is that, and it's something that's come out of philosophy of science, is that theory evaluation is inherently comparative. And the problem with the deductive form of an argument is that you really have no way of evaluating how deductive arguments can have probabilistic force, but it's hard to assign numbers as to exactly how sure are we of these premises unless you have some comparison class of alternative hypotheses that affirm alternative propositions. And so what I do in the book is I don't hang the argument, the cosmological argument, just on the fact of a beginning. I think there's strong evidence for that. And I think the alternative to denying that leads in a whole bunch of directions that I think are actually problematic for naturalists. So I think the thing that Phil's summary might miss is that my argument is what is not hung entirely on the evidence for a beginning, but rather it's an argument that has what philosophers call robustness, in that if you go this direction and affirm the beginning, you've got a theistic implication. But if you deny it, the cost to a naturalist in denying it undermines naturalism and provides additional support for theism. As much as I like Bill and the work he's done on the Kalam argument, I think it has force, I think it's very helpful, but I've added an additional wrinkle to this that I think is not commonly appreciated.
Okay, how do you and Steve differ in your approaches to the Kalam, Bill? Expound on what you think he means. What's this additional wrinkle that he has?
I think this is somewhat misleading, Kevin. The overall argument can be deductively formulated. Everything that begins to exist has a cause. The universe began to exist, therefore the universe has a cause. But when we ask about the empirical evidence for the second premise, that the universe began to exist, then that evidence is presented abductively. You look at the evidence of astrophysical cosmology and ask whether this is best explained by the universe having a beginning or no beginning. So the overall formulation of the argument is deductive, But the presentation of the scientific evidence in support of the beginning of the universe is abductive, given the best evidence of astrophysical cosmology and thermodynamics. The best explanation is that the universe began to exist. Now, the additional wrinkle that Steve mentions is that he wants to argue that if the universe did not begin to exist, that is still going to be problematic for naturalism.
Let's take a look at this next clip real quick. Steve offers his take on Phil's views. Here it is.
So, Steve, your turn to, what do you anticipate? Can you summarize what you think Phil's perspective is on this question?
Yeah, some of it's come out already, and it's been very helpful that the multiplicity of models that exclude a beginning or circumvent the evidence from observational astronomy or for some of the proofs in theoretical physics for a beginning, the multiplicity of models that deny a beginning, formulated by very leading cosmologists, suggests that we need to be at least uncertain about whether there was a beginning and maybe even doubt it. And the thing that we most certainly need to do is to refrain from using the evidence for a beginning as the basis of a theistic argument.
Okay, how's that as a summary?
Yeah, it's pretty much spot on. Maybe the only thing I would say is, I would say, even if we had no models that said the universe didn't have a beginning or the Big Bang wasn't the beginning, it wouldn't actually matter because the proofs of the beginning are not trustworthy. So it wouldn't matter at all if, let's suppose, every model that we had in that book was proven to be wrong. Wouldn't make any difference.
Okay.
Because the proofs are not very convincing, quite frankly.
Okay.
Yeah.
If I'm understanding Phil, he's saying we need to be agnostic about all these models because they are not yet proven trustworthy, Bill.
Well, presumably, we're going to get in our discussion today to the question of whether or not the positive evidence for a beginning renders that proposition more probable than not. But I certainly do think that the inability to formulate any mathematically coherent and empirically adequate model of a universe without a beginning does count strongly against the hypothesis that the universe is past eternal.
In this next clip, Halper gives the probabilistic conflict. Here it is.
But I do think there are what I would call is a probabilistic conflict. So let me try and unpack what that means. Basically, if you go back to, let's say, Tycho Brahe, who's a very famous astronomer, and he was like the greatest astronomer of his age just before the telescope. And he examined the Copernican model. And Tycho Brahe says, he gave arguments against it from physics, but he also said, but it contradicts Holy Scripture, which must be paramount. And I think science today says not only is Holy Scripture not paramount, but it's not to be considered at all. What happens when Holy Scripture seems to contradict the consensus in science? With that in mind, there are sort of three positions I think you could broadly take, right? One is to embrace the science and reject the religion. Two is to embrace the religion and reject the science. Or three, find some way to reconcile them. But notice that 2 out of those 3 strategies is going to lead you into a conflict. And we have some data. That's all hypothetical, of course. We actually have data on what people really think. So there was a survey in Time magazine of Americans, and they were asked, what would you do if a scientific fact contradicted an element of your faith? And 64% of them said they would reject the science. There's surveys of how many people think the world is less than 10,000 years old. And the answers do often depend on how you phrase the question. But it's somewhere between sort of 20 and 40%. That's why I think it's a probabilistic conflict. It's not that religion, or Christian religion in particular, forces you to oppose science, but what it does do is increase the probability that you will.
All right. Phil says on the one hand, there's no inherent conflict between science and religion. But on the other hand, the Time magazine survey shows that religious devotion increases the probability that one will reject scientific facts. And that may be true for whatever reason, Bill, but I'm wondering how that survey is relevant. Just being generous, Phil may have an aspect of Steve's book in mind, and that's why he even brings it up.
Well, if he does, I don't know what aspect that is, because this really is irrelevant to the truth involved. You could, with equal justification, point out that deeply naturalistic people would reject the science if the scientific evidence supported belief in the existence of God. In fact, look how Phil Helper himself rejects fine-tuning. Because he sees that this leads to theistic conclusions, he denies the fact of fine-tuning, even though it's scientifically well established. So these are interesting sociological facts about how deeply religious or deeply naturalistic people respond when the evidence goes against their beliefs, but they're of no philosophical significance.
Yeah. Could have been a bad day for the surveyor. I don't know. But next up, Steve talks about the first phase of the argument from his new book. Here it is, phase one.
Phase one of the argument, okay. If the argument is predicated on the evidence that we have of a beginning, that there are several very key discoveries from observational astronomy that have pointed back to a beginning point. You have the redshift data from astronomy showing that the universe appears to be expanding outward. If you back extrapolate that expansion, you get to a point of convergence where you can't back extrapolate any further, suggesting a starting point for the expansion and arguably the universe itself. Things like the cosmic background radiation that was first discovered in the 1960s, developments in theoretical physics, the singularity theorems of Hawking and Penrose, and the BGV theorem of Borde, Guth, and Vilenkin, that in one case I think provides a proof, in another case a strong indicator of a beginning. The thing about something in theoretical physics or attempts to make proofs is they're always predicated on certain assumptions or conditions. In the podcast, Phil, you did with Sir Roger Penrose, I was honored to be mentioned, even if it was in the mode of a critique. Just to make sure we're understanding each other, he critiqued me for not describing the conditions under which the singularity theorems would apply. I have an extensive discussion of that: the weak and strong energy conditions, the whole issue of quantum gravity inside the Planck unit. So I'm well aware of those limitations on the proof. So my conclusion about the singularity theorem was not that it provided an absolute proof, but a strong pointer to a beginning.
Yeah, Steve was being really nice there. Penrose really critiqued Steve in the video that was mentioned. But Steve says Penrose was given bad information and that Steve was misrepresented. He's trying to straighten it out now. Nevertheless, Steve recounts some lines of evidence for the beginning of the universe that you are also well known for, Bill.
Right. Meyer lists here some of the observational evidence for the beginning of the universe. He could have added as well the synthesis of the light elements, which cannot be synthesized in the stars, but required that hot, dense state of the early universe for their synthesis. And there are other advances in theoretical physics that he could have mentioned. The Borde-Guth-Vilenkin theorem that he referred to holds under a single, very general condition. And the most recent studies indicate that there are only about 3 classes of models that can fall outside that general condition. But all of these fail on other grounds to provide a viable model of a beginningless universe.
Now, here's a portion of Phil's response to Steve's first phase that we just listened to. He says there's confusion over 2 categories of the Big Bang. Here it is.
What's often happening is that there's a bit of a bait and switch. In particular, 2 notions of the Big Bang are getting confused. So in our book, we talk about one definition of the Big Bang, which we call the hot Big Bang. The universe evolved from an incredibly hot, dense state. And that theory says nothing at all about what came before that. It doesn't say whether there was a beginning of time or not. It just says the universe evolved from a hot, dense state. The other definition that we talk about for the Big Bang is the Big Bang singularity. So the universe evolved from a singular state. What we mean here is that the curvature, the pressure, the density goes to infinity. This is the sort of beginning of time, if you like. Now, all the observational evidence only tells us that there was a hot, dense state. It doesn't say there was a singularity. In fact, I would say there is no evidence at all that says, not any empirical evidence that says there was a singularity. In fact, you can't really get any empirical evidence for a singularity. It doesn't make any predictions. And in fact, there's something called the cosmic censorship conjecture, which I think is very plausible, that says actually singularities are hidden behind horizons. And in fact, if you could see a singularity, you would actually have a breakdown of causality, which would threaten the Kalam in the other way. It would threaten the causal principle, perhaps. So we can't see singularities. There's no observational evidence for them. And in fact, we did a survey of physicists, and I've done 2 surveys now. And this is very important. And the only question that we got a majority view on anything on was that the Big Bang should only be understood as the hot Big Bang, not as a Big Bang singularity. So when physicists say we've got evidence from the cosmic microwave background and the redshift and blah, 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 they're only saying the hot Big Bang. Okay. So this is not empirical evidence of a beginning of the universe.
Okay, Bill, how do you handle those 2 notions of the Big Bang, the hot and the singularity, in your work? I'm sure it's an important distinction.
This is a purely semantic distinction, Kevin. We don't need to talk about the Big Bang at all with respect to what it refers to. Rather, we can simply talk about the Friedman-Lemaitre Robertson-Walker model, which is the standard model in astrophysical cosmology. And in the FLRW model, the universe does have a singular beginning point. And the observational evidence that's cited by Steve provides empirical support in favor of this model. As you go back in time, the universe is in a state of gravitational self-collapse, and there is no known physics that would serve to reverse the collapse and bounce back to a new expansion. So while we cannot admittedly observe the singularity itself, you can't see it, it is the terminal point toward which the self-collapsing universe is headed. Moreover, we have non-observational evidence in the form of the singularity theorems, like the Hawking-Penrose singularity theorems and the Borguth-Vilenkin theorems, which are valid given very generally held conditions. Finally, I need to say that having a beginning does not imply having a singular beginning. Phil just equates the universe as having a beginning with its having an initial singular state, but that's just false. Models that do not feature a singular beginning are still finite in the past rather than past eternal. And so whether the beginning is singular or non-singular is ultimately irrelevant. In either case, the universe began to exist.
Next up, Steve talks about phase 2 of his argument. Here it is.
The part 2, here's the big point about that.
Go ahead.
If you have a beginning.
You have a beginning.
Okay, and if we're going to, any argument predicated on a beginning is going to create difficulties for a materialistic worldview. Because either before the beginning, which we have to put in scare quotes because time is beginning, or independent of the beginning in an ontological sense, there is nothing materialistic to do the causing, because what is beginning is matter, energy, space, and time. So on a straightforward conclusion based on observational astronomy, and I think the most straightforward reading of these proofs from theoretical physics, I think you have a not a proof, but strong evidence of a beginning, and that poses a problem for materialism, an explanatory challenge for materialism that it can't meet, that theism can meet, because if you posit an independent entity who transcends matter, space, and time, and also has powers of volition, you have the necessary conditions of an adequate explanation, causal explanation for the origin of the universe if it had a beginning. And I think one of the interesting things about the alternative cosmological models is that they always have to posit something that is separate from or transcendent from the observable universe we have. It may be a prior mathematical state, as in quantum cosmology, or it might be a prior Big Bang. But transcendence in the strict sense of the word as something separate from seems, I think, by all concerned to be something conceded as a necessary condition of explanation. Causes need to be separate from the effects that they produce.
Yeah, by the way, you often say logically prior rather than before, Bill, for the reasons that Steve pointed out. Do you agree that a beginning of the universe is a major problem for materialism or for atheism?
Well, I do, but I frankly think that Steve's additional wrinkle that he wants to add to the argument is unnecessary. The philosophical arguments and the scientific confirmations for the second premise that the universe began to exist exclude that the cause of the universe can be a material object. And so the notion that the universe has a material cause is already excluded by the philosophical and scientific arguments in support of premise 2.
Phil's co-author, Niash Ashforty, agrees with you, Bill, on an important point, and that's included in this next clip. Here it is.
And in fact, I would challenge Stephen, what empirical evidence could you possibly have of a singularity? I just can't see how.
Should we
Yeah.
pass that back then? So the hot Big Bang is not evidence of a beginning, and the singularity theorem itself is contested, says...
Well, we'll come on to that. It's more like we couldn't observe a singularity if there was one.
Well, of course, that's where the laws of physics would break down. I'm not disputing that. The point is that the back extrapolation that's been involved in inferring the hot Big Bang state takes you back to a point of convergence past which you cannot go. And that's a consequence of the redshift as much as it is the consequence of the singularity of Hawking and Penrose. The point that I'm making is that it's a reasonable conclusion to believe that the universe had a beginning. There's no way of getting beyond that hot Big Bang to something before. This is something that in the book, he agrees with William Lane Craig that there's no evidence for a beginningless universe.
But we also said there's no evidence for a beginning universe.
No. There's a difference between evidence and proof. And I think what happens throughout your book is that there's an absolute 100% standard of proof required for anyone who wants to say that the universe had a beginning.
That's not what we're talking about.
And well, that's what to suspend the Borde-Guth-Vilenkin theorem simply because there are models that could circumvent its conditions is to require an absolute proof.
No, it's not. It isn't. It just isn't. It does. We're not looking for an absolute proof. That's just not
I'm
correct.
saying that there's evidence of a beginning because the back extrapolation...
Well, can we agree there's no empirical evidence for a singularity?
Well, you wouldn't get an empirical...
Right, all right, so
singularity
we are
is an artifact of mathematical physics.
So let's find the common ground.
Yeah,
we agree.
Right, but that's a red herring because no one has ever said that.
Well, hang on.
Let me just get this.
The singularity has a technical definition in physics, which is a place where the laws of physics break down. There's no possibility of empirical evidence of a singularity. But
it's a hypothesis based on extrapolating the mathematics.
Conjoined with general relativity that would lead you to think that you're getting to a singularity or a near singularity.
Phil is adamant about there being no empirical evidence of a singularity, but Steve agrees, but there still seems to be some contention going on here, Bill.
Now, this objection is just silly. Meyer is correct. A singularity cannot be empirically observed. But it does not follow that we can't have good evidence that there was a singularity in the past. Moreover, we have good theoretical grounds for postulating a past singularity, namely the singularity theorems we've talked about. But once again, Kevin, notice that they both still seem to be laboring under the false assumption that having a beginning implies having a singular beginning. It does not. and therefore the unobservability of the singularity is simply irrelevant.
Just so I'm understanding it, Bill, a singularity is mathematical and conceptual, and therefore can't be empirically verified. Am I correct?
Well, it can be empirically verified. It just cannot be empirically observed.
Yeah. Okay.
And that's because it's a point of infinite density at which all the laws of physics break down. But we can have good empirical evidence for a past cosmological singularity.
A couple of more clips today. Steve really gets on a roll, and there's some good summations here. Here's the clip.
Because they need this quantum gravity theory,
And this
which
is where
we
I
don't
would
have.
disagree, Phil. I think they're pointing to something, and Borguth-Vilenkin, which is not based on as restrictive conditions, I think points more decisively in that direction. But the other part of my argument is that if you decide you don't want to depict the beginning of the universe classically in general relativistic terms, as it were, and you invoke a pre-Planck time quantum description of the universe, you invariably get a universe that is depicted as a superposition of essentially possible states of affairs. And the depiction is essentially not materialistic, it's mathematical. And Vilenkin has pointed out that this is very odd because you have this whole mathematical apparatus that precedes the beginning of the universe in quantum cosmology, which is taking into account the limitations of the singularity theorems, the conditions that have to be met. It says we need a theory of quantum gravity. And you end up with a system that has a big hairy equation, the Wheeler-DeWitt equation, that needs to be solved to give us a universal wave function. And the idea is that if the universal wave function includes among the possible states of affairs in superposition a universe like ours, it will then constitute an explanation of the origin of the universe. But that mathematical apparatus that precedes the origin of the universe is mathematical, it's conceptual. So what Vilenkin has noticed is that he says, before there's matter, space, time, and energy, what tablet could these laws referring to that whole apparatus be written on? He said, if math is the domain of the mind, are we actually saying that the universe has come out of mind? And what I'm arguing is that when the straightforward Kalam argument rendered, however, whether as an inference to the best explanation or as a deductive argument, is circumvented by alternative models of cosmology, that something is affirmed in those models that has its own theistic implications. In particular, unexplained fine-tuning, or in quantum cosmology, the big hairy equation that has to be solved, the Wheeler-DeWitt equation, is solved by the physicists making arbitrary choices of the boundary constraints they're going to apply to the equation in order to get a universal wave function out that includes a universe like ours. It's a teleological modeling where there's an information input by the physicist into the mathematical apparatus to get a wave function out that will provide an explanation of the origin of the universe. Well, that's intelligent design. They're modeling the input of information into a mathematical apparatus to model how the universe could have come into existence. So yes, you can get around the beginning, but at an epistemic cost to naturalism. And that is always the affirmation of unexplained fine-tuning and often some very, very wonky physics, which is why you're correct to say that you're probably right. Most of the 25 models are not going to be correct.
That was a long clip, I know, and a lot of information, Bill, but maybe you could unpack for us and elaborate a little bit on the epistemic cost to the naturalist Steve is talking about whenever mathematical modeling is engaged.
This, once again, is the additional wrinkle that Steve wants to add to the traditional Kalam cosmological argument. He thinks that if you posit this abstract mathematical realm prior to the beginning of the universe in order to explain our universe, that would involve fine-tuning, which itself points to an intelligent designer. Well, I think all of this is unnecessary, Kevin. An abstract mathematical realm cannot cause anything because mathematical objects have no causal powers. Abstract objects, by definition, are causally effete, and therefore it is metaphysically impossible to explain the origin of our concrete universe through some abstract mathematical realm. The hypothesis is absurd.
And here are the highlights of Phil's response to what you just heard from Steve.
First off, he quoted Alex Valenkin, and I think that's a misquote because Alex Valenkin doesn't believe in a God, right? He believes that the universe does have a beginning, but it doesn't need a cause. Okay, so he has this. He does mention like where could the laws of physics be written? You know, I think that was honestly a bit of a
Turn of phrase.
It's a turn of phrase. Well,
I thought
it's
it was
more,
an insightful
hang on.
rhetorical question.
Hang on. I think
Never claimed that he believed in God.
Okay,
nor does my
let's
argument
make that
depend
clear.
on what he.
Right, let's make that clear because when you have that comment, it sort of hints at, oh, he's thinking there's a mind. He's not thinking that. In fact, if you read his book, Many Worlds in One, is incredibly anti all of the arguments that Stephen and other theists put forward. He basically, although he thinks the universe had a beginning, he doesn't think it needs a cause. So out with the Kalam. He also thinks like the multiverse is real and soul's fine-tuning, so out with the fine-tuning argument. Basically, what was going on is that they came up with this theory called inflation. So Alan Guth came up with this theory called inflation, which has this accelerated expansion.
In the very early moments of the universe.
This
This inflationary period.
And it was thought by Valenkin, actually, he was one of the pioneers of this, to be eternal into the future. So once inflation starts, it never stops. It makes universe after universe after universe. So it's eternal. So they asked the question, well, if it's eternal into the future, can it be eternal into the past? And their conclusion was, no, it cannot be eternal into the past. So inflation requires a beginning. And what's in the paper is that there's a boundary to the inflating space. Okay. Now, first off, other people have challenged that. This is not like an agreed upon fact by everyone. There's a recent paper by Lesniewski, Davis and Essen saying actually they made a mistake and it's actually you can have an inflating space that goes back into past. There are other papers that have said this. Now, again, the point I want to emphasize is no empirical way to adjudicate this disagreement. Okay, if inflation happened and it's eternal, and suppose there's some beginning to eternal inflation, we are not going to see it empirically. So that puts caution on this conclusion, right? Because we want science to be empirical. This is kind of why I think we need to emphasize the uncertainty here. We're in much more uncertainty about these topics. So basically, we have to be agnostic about these sorts of issues, right? It's just not correct to say that these points will begin. In fact, Alan Guth thinks the universe is eternal into the past, right? And surely Stephen knows this, right? I mean, this is very well known. And so the bottom line is, yes, people make assumptions. This is what you have to do physics. And it's nothing unusual. Coming up with new fields is nothing unusual. It's been done before. That's what the Higgs field was. This is part of doing science.
Okay.
Several things there, Bill. We'll start where he started. Does it matter that Valenkin is an atheist as far as evaluating what his theories show?
Of course not. In fact, the very fact that Valenkin is not a theist makes his defense of the beginning of the universe all the more impressive. No one can accuse him of being biased in favor of a creator. Now, I wish everyone were a theist who believed in God, but in one sense, I'm actually glad that Valenkin is not a theist because no one then can accuse him of confirmation bias in his strong defense of the beginning of the universe. Now, since Valenkin holds that the universe began to exist, he is forced to assert that it came into being from nothing, which I think is metaphysically absurd. A few years ago, he wrote an article in the online magazine Inference in which he defended this extraordinary hypothesis and to which I have in turn responded in my published work. And basically what Valenkin argues is that if the positive energy and the negative energy in the universe are exactly equal, then they cancel each other out. And so the net energy is zero. And so the universe can come into being out of nothing. Well, this is a terrible argument. This is like arguing that if my debts and my assets balance exactly, then my net worth is zero. And so there is no cause of my current financial situation. Christopher Isham, who is Britain's premier quantum cosmologist, has said in response to this argument, there still needs to be an ontological cause of the positive and negative energy in the first place, even if on balance their sum is naught. As for Alan Guth, as I've shown from his own correspondence, when he says in that debate with Sean Carroll that the universe is probably past eternal, he's talking about Sean Carroll's model, which features a reversal of time's arrow in the past. If you go back in time, at some point, the arrow of time flips over and runs in the opposite direction. Well, this model, therefore, actually implies rather than avoids the beginning of the universe. That time-reversed universe is in no sense in our past. It is in no sense earlier than ours. Rather, what you have here are two universes originating from a common beginning point. And finally, we see once again Skydive Phil's naive empiricism. You don't need to observe things directly in order to have good evidence for them. Physicists today do not generally challenge the Borde-Guth-Vilenkin theorem. It is well established. Rather, what they try to do is evade it by denying the single condition that it requires. But as I've said earlier, there are only about 3 classes of models that will enable you to avoid that condition, and none of them is physically viable.
I wanted to ask you real quick, Bill, about an impression that I get on Steve's approach. You emphasize that scientific discoveries can serve as a premise in a cumulative case. Do you think Steve agrees with that, or does he want to incorporate theism more directly into the scientific method itself? In other words, replace methodological naturalism with a more holistic or eclectic method.
In our previous dialogue, Steve has shown himself to be quite open on this question, that he's not necessarily propounding a creation science that would see the inference to a creator as a part of science itself rather than a metaphysical conclusion. For my part, I don't see any need to appeal to the fine-tuning of the mathematical realm, as Steve does, since by definition, abstract objects are causally effete, and therefore they cannot be the cause of the universe. There has to be a transcendent, concrete object that is the cause of the beginning of the universe.
Next time, we'll look at their discussion of the fine-tuning argument on the next podcast, Bill. And Bill, you better be cautious. You may get drawn into some 3-hour debates after this one. Any more thoughts or loose ends, your impressions to tie up today?
Phil Halper constantly creates a false opposition or choice between God or a beginningless universe. And that's not the choice. The choice is between a universe with a beginning or a universe without a beginning. Which is more probable in light of the evidence that the universe began to exist or that the universe did not begin to exist? Notice that that is a religiously neutral question, which can be found in any book on astronomy and astrophysics. It has nothing to do with God. So we should not be playing off God against the beginninglessness of the universe. The question is a scientific question that is theologically neutral. In light of the evidence of contemporary cosmology, is it more probable than not that the universe began to exist?